So I'm going to be doing a little presentation on the research that I did at the University of Connecticut last year. So really just the interesting parts of it. I'm going to spare you all of the boring details, but start off with who I am. So I'm a first year, my name is Dan LaChance. So I'm a first year cybersecurity major. I'm from like right around Hartford, Connecticut. So I like music. I'm a reformed rower, so I used to row for like 3 years in high school. Big Bills fan. I've been to like 12 games or something. Then I was on my high school robotics team. I'm a big fan of FRC, if anybody did that. And I have two dogs back at home. Left one's Chance, right one's Mia. They're great. All right, so Chance LaChance. He came named Chance. Okay, we did not name him Chance. We're not that obsessed with our last name. But yeah, so one thing that most people probably don't know about QR codes is that they have error correction capabilities. So you can lose a fair bit of the data and they will still work. If you want to grab your phone and scan them, all three should scan. It's just gonna like give you an invalid number because like iPhone and Android scanners, they don't actually scan all of the data. They just like look for certain things. So if you have like a QR code app or something, you'll be able to see all the data. So all of them will scan. That's the important part. So you may have seen like the error correction capabilities in like the Google with the dinosaur and everything. And if you see one of these QR codes with like a logo in the middle, pretty much what they do is they just have a high error correction level, which I'll get into error correction levels in a second. And then they just like slap their logo in the center of it and overwrite some of the data. So something that you can actually tell like which error correction level it is. There's L, M, Q, and H. So and those percentages is how much of the data that you can like completely lose or wipe out, and the QR code will still scan. So this one's level H. It's the highest level. H stands for high. So it can lose 30% of the data, and this QR code will actually still scan. Again, same thing. It's just going to give you an invalid phone number because iPhone scanners stink. All right. So a little bit about a QR code structure. The left side up there, those are all the error correction blocks. And the error, if you don't know too much about like error correction, basically you have a bunch of extra bits on top of the data in order to check against with like the data bits. So if any of the data bits are changed or the error correction bits, the QR code can recorrect itself. And then down here, if you're ever wondering what these are, they're to track the position of the QR code, and this is the orientation block. And then there's just a bunch of extra metadata and stuff that isn't really too important to what I'm going to be talking about there. All right, so how can we use this in a malicious way? Some of you may be asking. So you can store secret data in there. Can you tell the difference between those two QR codes? The answer is no. Do not lie to me and say that you can. You cannot. If I showed you both of those, you won't be able to tell, unless you really paid attention like this. So if you superimpose both of them and highlight all of the differences, you'll get something that looks like this. And I went in there and I actually put some of this extra data in there. And if you pull it out, it's just a bunch of binary that is encoded with UTF-8. And you can just get the secret message, discard, voted for wrong candidate. Again, I was in the voting lab, so I had to make everything voting related. All right, so electronic voting process. This is short section. It's kind of boring, but I'm not sure if New York uses voting machines. Does anybody know? Or is it like all hand ballots? Okay. Connecticut is all hand ballots because of stuff like this. So basically, you go to like an iPad, something like that, and you type out like which candidates you want to vote for, and then it prints out this ballot and this QR code. So the QR code is the only thing that's actually scanned from the tabulator and inputted into the voting database, where all the votes are tallied and everything. So again, that QR code is the only thing that matters. Everything else is just for like audits. So if you blow up that QR code, you're actually, if you try and scan that with your phone, you can't, because voting tabulators have special QR code scanners, and they can scan QR codes that will register as like incomplete or like invalid to most scanners. So keep that in mind, because a lot of workers, they can't, influence an election by scanning something. They can't scan the QR codes and like throw out a ballot because their scanners can't find stuff. But if they were to store some secret data in there that they can scan, then they would be able to like use their own scanner, as I'll show you later on, and they would be able to like throw it out. So that's just it's a thing that I hope is not happening. All right, so there's this a bunch of guidelines called the voluntary voting security guidelines. The 2.0 one came out like a few years ago or something, and they basically just outline everything that a country should be doing if they're using all the security measures they should take in order to comply. So one of the things that it explicitly says is that you should not be able to extract any personally identifiable information from the QR code. With this scheme, you would then be able to. So it voids that compliance. All right. So now the fun part, how this process actually works. If you don't know like what Zebra Technologies are, it's just this company that makes a bunch of scanners. So they have a QR code scanning library that's open source called Zebra Crossing, and that's just the one that I built up my scheme from. A lot of places like grocery stores and stuff like that, or if you're like scanning tickets to get into a sports game, they'll often use Zebra Technologies. So that's why I use that. So I just wanted to talk about like some data structures and just some terms that I might be using. So obviously bytes, it's the same thing. Don't worry about. I might use it in a weird case, but blocks are pretty much just bytes that they're mapped differently. So if I go back to this image, each of those like outlined areas, it's 8 bits, but it's not a straight, just like binary readable. It's in a really weird orientation, but it's like that for a reason. And it's not really important right now, but then when we're going up from the blocks, you have code words. Pretty much it's just a byte of data that constructs the data area. That's the general definition of it. It's just something that to organize data in order to make it into a bit matrix. So bit matrix is this one right here. It's basically just a visual representation of all of the black and white squares. So the blacks are X's, the whites are just null. And they're just spaces, not null. And then the bitmap is just like a larger picture of it. You can do some different things with both of those, but not too important right now. All right, so the classes that I was actually working with in here is I created a secret encoder class. I created an encoder base. I followed that line down through the multi-format writer. So that's the multi-format writer pretty much just follows, or it takes in some data and which like code you want to write it to, and then it calls a different class from there. So it would then call the QR code writer, and then I changed a few of the classes in the encoder to put some of my secret data in there. And then the decoding is pretty simple. The secret decoder, it's a class that I wrote basically to pull in like an image from a file, run it through the normal decoder, and then from there I'll get the bit matrix, and from the bit matrix, I can pull out my secret data. And the decoder class I also used for, that's where I pulled out all the secret data from the bit matrix. All right, so encoding, if you want to, I pause to read for a second. I know it's a lot there. I don't want to overwhelm anybody, but start with, so the first thing that I do when I'm encoding is I pass the secret message and data down to the encoder class. It just goes down that lineage through the multi-format encoder and through the QR code writer, and it goes all the way down to the QR code encoder class. And then from there, I create a class variable for the secret data array, convert it to binary so that I can actually overwrite some of the bytes, and then do some stuff that was already there, basically just creating the QR code matrix. Then I would call, when it calls the get error correction bytes, so that whole left side of the QR code from that image that I had before, those are all the error correction bytes, so it needs to get and create them in order to implement them into the matrix. So in that get error correction bytes method, I wrote all this stuff. So if it's depending on the error correction level, there's a certain amount of the data that I can overwrite. So those are the percentages of the error correction data that I was able to comfortably overwrite. So there's 11%, 24%, 38%, and 48%, roughly. I know that it's supposed to be like 7, 15, 25, and 30, but some of the bytes will actually be correct for the secret data. So if you think about it, I have, say, a random string of like a few bytes, and that's going to be like, what, 45 or 48 bits, and some of those bits are going to be ones and zeros, and some of the bits already in the QR code are going to be ones and zeros. So if those align, then you can increase the amount of bits that you can encode. So that was actually my research, seeing how much I could push it to. Though just changing a few of those numbers, it was a lot of setup just to change a few numbers, but that's what I did, and I found that those were the comfortable maxes that I could do, and I did a whole statistical analysis to get those numbers as well. So about 99% of QR codes will still scan with those numbers, and that was good enough for my research. So then from there, I copy the bits into the error correction. That percentage, Emax, my variable, the first Emax percentage of the bytes, and I copy them over backwards because I needed to. Question?
So are you using a QR generating library?
Yeah, it's Zebra Crossing if you want to look it up. It's open source, should be on GitHub if you want to look through it yourself. And follow along with some of these classes if you're interested. And you can always ask me about it later. I love talking about this stuff. All right, so once I have that error correction bytes and I change some of those, everything pretty much is done for me. I send those error correction bytes into the normal QR code generator, and then it spits out a QR code that looks very similar but is not. And so for decoding, it's kind of just like the same process but in reverse. So on the left side there, you should see it's kind of similar to what's on the other side. So first I start off with calling Zebra Crossing's get matrix file, and then I resize the matrix because the matrix has, in order to extract the pure bits, that's what they call it, I don't need that array, I just need the ones and zeros. And so from those ones and zeros, I can send it to a decoder object, and from the decoder object, I can pull out my certain set of bits that I need in order to decode that secret message. And it's all done in UTF-8 as well, because UTF-8 is what a lot of the literature prior to my experience used. And so, demo time. This is going to be short. It's just going to be showing. I used BlueJ for this. Don't judge me. My mentor told me to use it. It's horrible. It's an IDE, but it's terrible. So BlueJ, you know how you in like most IDEs and stuff, you can it formats all of your structures for you. Not in BlueJ. You can like point to different classes and like it's very. The reason that I used it is I had a lot more control with it than a normal IDE, and there's no autofills for stuff, so I wasn't able to rely on that crutch. Yes, Chase?
Is this similar to Scratch?
No. Here, let me open a class. It's Java. It's Java, but no, it's just there's no dark mode for it, which is so sad.
My friend tried to compile it and put in dark mode.
I wish. All right, so it'll open up this prompt when I run that, and it'll type an input for my secret message. Any ideas? Anyone want to put it? Number.
Gumper.
Oh, Gumper. Sure, Gumper can be the secret message. Whoops. Okay, Gumper is the secret message. And then, what's the file name? I'm just going to say file. All right, so it created it. Then it actually created two of them. So let me open both of these up, blow them up. So one of these has, they will both scan the same. You can try them. They'll both say, they both, I don't know what I had them say. Oh yeah, I know what I had them say. Okay, so if you scan both of them, you can try it, and they should scan the same. They should be the same, same YouTube video if you want to try it out. But can anybody really tell the difference between these two? A little bit? A little bit? If you're looking for it, you can. And that's just, if you want to focus on the center, like you can point out a couple of the differences. Like I know right around here, there's definitely some differences. The center, the just left of the center should be a little bit different. But say you're posting this up on a wall, it's not going to be really any different. Nobody's going to notice, and nobody's going to be able to tell if you're in voting security. But I can go into my secret decoder, and it's going to ask me for the file name. I had it as file, and then ignore that. You can see that it says Gumper, and then it's just going to give you like a random set of strings afterward.
Mm-hmm.
So, yeah, pretty neat. All right, there we go. Any questions? That's about all I had. Yeah. It's just anytime you create a QR code, that random set of strings, it's just going to be dependent on what you put in your message. And so I pulled, you know how I had that Emacs variable? So I'm pulling that percentage of the error correction bytes and then converting them. So if the message is only like 5 bytes long, but I'm pulling like 15, because that's the maximum message length, then it's going to just put whatever, it's just going to convert whatever was there into, yeah, it's to max. Because one thing, in one of my earlier prototypes, I had the first 4 bits be, it just tell you how many characters it was, and then I couldn't, with that, I mean, it worked and it was prettier, but I couldn't store as much information in there. And that's really what I was trying to do with my research. Yeah.
To what extent does a communicator need to already have established the rules with the person they're trying to give the message to before the QR code is displayed? Do you need to say specifically which bits are going to be flipped?
What you would do is probably just say, pull the first 10 error correction bytes and convert them to UTF-8. That's all you
But
have
the
to
error
do.
correction bytes are necessarily included in the QR code.
Yeah, the error correction bytes, if I go back to this picture, those error correction bytes up here, that whole like dark gray left side, they're always in there. So your QR code is always going to have but depending on the error correction level, it's going to have between like 20 and 60% of the QR code face is going to be error correction bytes. So they're always going to be in there. You should be able to pull out some of them. Yeah. Ash? Yeah, so where is that? There it is. So yeah, LMQH, it's low, medium, qualitative, something like that. Some qualitative, something like that. It's just some weird name that they decided to throw in there, and then high. So 7%, 15%, 25, 30%. Those are the only important numbers you really need to know there. And if you're ever interested, you can tell how many or like what level it is just by looking at those bottom left 2 bits. All right. Any other questions?
I have one.
Anybody else? Sure, Chase.
Do you ever wish you had something that you could wear a QR code?
Like around my neck? Something like that? Just like if I want someone to just wear like a badge of honor, you know?
Yeah.
Just a QR code. Sometimes I dream about that. I don't know. Maybe like a lanyard?
Oh, maybe?
Maybe?
I got one for you.
Wow.
Thank you, Dave. Oh, yeah. Okay,
Thank you.